As discussed earlier, there are many exciting reasons for using Xterm.js, and some of the top uh, ecosystems and top environments use this concept of a lightweight throwaway terminal because it is able to use a terminal plus WebSockets to give this really impressive interactive workflow. So let's go ahead and show how to build this ourselves. First up here, we look at the tree structure. We have a cargo.toml file. We also have a Docker file. We also have a front end, which has index.html, and also the Xterm code downloaded. Now, the reason the code is downloaded here is to make it completely offline. Another option would be to use a CDN, but one of the benefits of potentially building containers with a offline version is that you don't need to call out to a network resource. You can have it completely isolated and also potentially more secure because you have 100% verified this. We also have a makefile to help us out, and we have source main.rs. So a lot of really cool files here to explore. So first up, let's go ahead and take a look at cargo.toml. And what we can see here is that we have Actix web here, Actix web actors, also Actix files, so we can interact with the local file system. And we also have the logging and some other things as well, like Nix, which allow us to talk to a terminal, and then Tokyo, the async library. Now, if we go into the main.rs here, actually not a ton of code, but let's go ahead and walk through this and take a look at what it does. So first up here, we have all the imports, and then we have a const, which is our buffer size. We also have a control here, which allows us to work with child PIDs and master file descriptor, etc. And then once we go through here, we have some controls that let us do things like resize or terminate. And then finally, we go through here and have some implementation of the actor. And this allows us to have a WebSocket connection. And this is what is going to do the heavy lifting in communicating with Xterm.js. You can see here that we are able to spawn, work with the text, move things, etc. And then if we scroll down here as well, we can have a stopped function. Now, if we get into the handle as well, this is where we would handle the output. This stream handler can deal with the binary data. We can ping. We also have a message here that allows us to interact with the rows and the columns and resize things. And we also have a setup. So this is our initial window size. We're able to work with a shell as well. This is an exec shell, so we can run those terminal commands. And then we also have some logic here that helps deal with saving state. We have a setup reader here as well. And then finally, at the very end, what we have here is the index, the other routes that get handled. And then we show that inside we invoke the main function for Actix web. So we have a web service here that is able to handle both the regular route, which is at / and also the WebSocket route, and then we bind on port 8443. So that's the overview of the Rust code. Let's also take a look at the index here and see that it's also not terrible in terms of size, only 85 lines. And we have right here at the head terminal, we have Xterm.js here, and then we also have a new terminal that we deal with as well via a const, and then we open up a document, which is the terminal by ID. We resize it, and then we have our traditional WebSocket function here. So the WebSocket does a connect, and then we have an on message, and we have an on close. So these are the traditional components of a WebSocket routine. And then finally, we have things like resizing and dealing with the data. So not a ton of code there really to deal with the WebSocket, because Xterm.js, which I included, does all the heavy lifting. Now, one thing to remember is that we also are going to use a Docker file. And let's talk through the stages here, why they're important and why they matter so much for what we're doing with WebSockets and also with Xterm.js. So first up, one of the benefits of using a language like Rust over Python is the concept of tiny binary deploys. So in this case, we can build these very, very tiny binaries here that show us essentially the powers of a modern compiled language. If it's a scripting language, there's all kinds of strange dynamic dependencies. In this case, I can build these very small binary releases. And in fact, one of the things that you could do is actually run that command locally yourself to just experiment with, hey, what's happening here? Why is this so cool? Well, we can run that command. We can do cargo build space -- release end strip. So basically remove out any kind of debugging symbols. We don't care about that. We want to make a very tiny binary, and it shows you how this enables you to build a very effective ephemeral environment. And now all we have to do is do du. Let's go ahead and go through here, du-sh, and then we can go to target, and we can go to release, and then we can go to Xterm.js right here. And let's go ahead and take a look at the size of this. We see that it's 4.4 megabytes. So very, very tiny binary. And all we have to do is put some kind of containerized environment on top. And that's what the next step does. So here we go to Debian Bookworm Slim. And inside, we then take that binary and we put it into a very tiny container. Now, there are some tricks here to think about. So one, Debian Bookworm Slim, if I remember correctly, is about, let's say, 60 megabytes or something like that. And then we install some different dependencies. Maybe you want to put Bash and Z Shell and SQLite, etc. And then we copy those inside, and then we build out our executable that runs on port 8443. So this could be made into some other container as well. So it doesn't really matter what is the end target for your builder, but this does play a huge role in the kind of terminal you're building. Maybe you're building like your own cloud system, like you're a cloud provider in Europe and you want to build a customized command control, or you're a vendor that makes hardware. How would you actually go through here and build this out? It really depends. Like, do you have your own custom container that is smaller maybe than 60 megabytes? Maybe you're using something else. Maybe you're using Alpine, which can have a runtime of maybe 5 megabytes. So you can build these incredibly small environments with Xterm.js. Now, next up, what we'll do is we'll actually first run this without using a container, just to show the power of WebSockets in action with Xterm.js. So I'll type in fact, well, since we have a release, we don't even have to do cargo run. We can just do release here, and we can do Xterm.js. Once we run this, it's available now on port 8443. There we go. And now we've got a full terminal that accesses our full operating system. So there's a little bit of danger here in the real world, because it would have access to our entire operating system, file system, and we can do anything we want. And this is why the container aspect makes things so powerful. So if we run, again, htop, right, you can see all the different things on my machine, but still pretty cool. Even if I wanted to build specialized tools that work in the browser, right, I've already got an awesome solution. But we can go further, and what we're going to do next is we will actually go ahead and build this container. So if we go to Dockerfile here, right, all we have to do is type in docker build, and in this case we're going to call this one Xterm, and we'll go ahead and build that right here. So it'll take a little bit of time because it's going to do this release, right, where it's going to build this stripped release that's 4 megabytes. Then it's going to take all of that and it's going to push it directly into our Debian file here. And then once that's done, we're able to get a ephemeral environment that uses all of the benefits of this shell. So we'll go ahead and let this thing finish here. Great. And now what we can do is go to Docker image ls. Aha, here we go. We see that it's about 111 megabytes. So again, we could make this thing a lot smaller depending on the needs of the company I'm working with, or the consulting client I'm working with, or whatever it is I'm trying to do. Maybe we could get it closer to 20 megabytes, but still 100 megabytes is not bad. And let's go ahead and run it now. So we'll type in docker run. And in this case, we're going to run it on 8443. And then we're going to actually, we can just run the image ID here. So let's go ahead and copy that and paste it. There we go. So now we see it's running in foreground mode. So this will be a little bit different once we go over to the terminal. We see that before the connection was lost because we got rid of that process. But now, look at this. We're inside of our own ephemeral environment. And look at this. We can type in which SQLite 3. We got SQLite 3 here. We could play around with that. We could type in which ZSH. We got ZSH here. And if we type in htop, right, htop's not installed because this is a very small ephemeral environment. Instead, we just have regular top command. And even top is not installed because we have a very tiny environment. So basically, in a nutshell here, we have a really cool environment to play around with that we have basically all the control over, right? We can decide what it is that we want to do inside of this ephemeral environment. We can build custom tools, etc. So Xterm plus these throwaway environments with Docker are really amazing, especially if you get into building it with Rust, because Rust allows you to build extremely high performance, but also safe and also small containerized environments for building solutions with Xterm.js and WebSockets.